Hello everybody, this is Mr. Joseph. I am trying to help y'all graph polynomials today and factor. So this was our homework that we did, and as you can see, this first one has 4 terms. So most likely we are going to be able to use factor by grouping. So I'm going to group the first 2 terms, leave the sign in the middle, and group the next 2 terms. I think one thing you have to keep in mind is that what I highlighted above, this is our original. So whatever math we do here or any manipulation, we should always be able to go back to where we started from. And that's a really quick way for you to check. So when I look at our first 2 terms, I ask myself, what can I divide out of each of them? And I hope that we can see that I can take out x squared out of each of them. So they both have an x squared. And the next question I'm going to ask myself is x squared times what would give me back x cubed? And I hope that you see that's an x. And x squared times what would give me 6x squared? I hope that you see that's a 6. And from there, I'm going to move on to copy my minus sign. And I am going to now look at these next 2 terms. We see that both of these terms do not have an x, so we will not be able to take out an x. So what is the biggest number I can divide both 4 and 24 by? I hope we see that is a 4. And remember, I said earlier that you want to keep the original equation in mind, because what we're really asking ourselves is -4 times what is going to give me -4x? And that's going to be an x. The way I set up these problems with keeping that minus sign there will always lead that first term to be positive. So that's just something to keep in mind. And then the next term is -4 times what gives us -24. And I hope that we see that's a positive 6. So when you do factor by grouping, you know you've done the question correctly if these 2 terms turn out to be the same, as you can see here. And what we're going to do now is we are going to take out what both of these terms have in common. I hope that you see they both have an x plus 6. So I'm going to factor out an x plus 6. And x plus 6 times what will give me this part is going to be x squared. And x plus 6 times what is going to give me this next part, which let me highlight in a different color. This part, I hope that we see that is -4. So that is that's like the mathematical explanation of why that works. But something else that you can do is you can just see that we are taking the outside terms, which is this, and putting it in one parentheses and copying over one of the x plus 6. So the mathematical reasoning is we're using greatest common factor. And if you just like shortcuts or you're just trying to get it straight in your head, you can think of taking one of the similar terms and then taking what's on the outside and putting it together. And as you can see, we have x plus 6 times x squared minus 4. And then the next question we ask ourselves is, can we factor it any further? So if you see this, I hope that you see that as a difference of perfect squares. So I can do x minus 2 and x plus 2. Because -2 times 2 is -4, and -2 plus 2 is 0 in the middle. So remember that is a difference of perfect squares. So when we factor this all the way down, this is what we get. Okay, so that's the first part, is factor if you need, because it's going to tell us information. And I'm going to go ahead and skip to part C, which says find the x-intercept, zeros, roots, and solution. So all those terms are used interchangeably. So I'm just going to set all of these equal to 0. And I'm just going to show all my work. And as you can see, you can get -6, +2, and -2. So these are all my x-intercepts. So I'm just going to go up here and I'm going to write them because we're going to erase all this. So I'm just going to write them up here so I do not forget them. So those are my x-intercepts, and I'll keep that colored in green. So that's how you do that part. And now I'm going to erase everything. Let's get the bigger eraser. Okay, as you can see, my erasing skills are on point. And next, we're going to look at question B that says, what is the y-intercept? So, as you recall, we have g of x equals this. This is called standard form. And then when we factored, we had x plus 2, x plus 6, x minus 2. This is called factored form, factored. This is standard. So you have to decide which one is better and which one gives you information. So for instance, if I'm trying to find a y-intercept, I think standard form is much easier because all I have to do is I have to substitute 0 for all my x's. However, I hope that you see, because every term has an x, it's always going to be the number at the end. So we get -24. And remember, g of x means y. So we have 0, -24 for our y-intercept. And I'm just going to go above and just write that up there so we remember. Okay? So we have found our y-intercepts, we have our x-intercepts, we are getting closer to where we want to be. The next part is question D, determine whether the leading coefficient is positive or negative. So when you looked at it in standard form, the leading coefficient is a number in front, which I hope we can see here is a 1. So that means it is a positive leading coefficient. So we're done with D. Letter E says, is the function even or odd? So I would look at my highest degree, which is a 3. So I know this is odd. And if you were looking at it in factored form, you would count how many factors you had. So 1, 2, 3. And now, if you remember in class, we had a chart that kind of tells you the behaviors based on whether the leading coefficient is positive or negative, or odd and even. And I hope that you remember that if it's positive and odd, it's going to look something like this. So I call this down, comma, up. We're going to start our graph down and we're going to end up. So this is the end behavior aspect of the problem. And then G says, does any zeros have a multiplicity? A multiplicity is when one of the x-intercepts repeat. And as we can see, none of the x-intercepts repeat. They are all unique. So no, all of them have a multiplicity of 1. So pretty much doesn't do anything, or we don't have to think about it when we graph. So the next part is just graphing it. I'm going to show you how quick that can be. It doesn't have to be perfect. So my y-intercept was 0, -24. So I just put it down there. I have a +2, a -2, and a -6. So remember, you always start on the left side, and we are going to start down because our end behavior tells us we start down. So with polynomials, you just go through the points, through the points, through the points, through the points. And then voila, you have a graph. So this one was a nice example because there is nothing strange happening with the multiplicities. But if you look in our folder or just look up a guide on end behavior, it'll kind of tell you where to start and where to end based on whether the leading coefficient is positive or negative, or if the if the degree is odd or even. And that's it.